Bismillahirrahmanirrahim. Today I am going to tell you how to do the chromosomal localization of the genes. For this purpose, we should have the three things. The first one is the map chart to visualize the gene. And the second one is that we should have the position of the genes. Like this is a start position and end position of the gene. Then how you will get this position. You can get this by searching on the NCBI database. You will just copy this and go to the NCBI database, and this interface will open. You will just click on the gene and here you will paste your gene. When you will search this, then you can easily get the start and end position of the gene. So here it is a range and this is start and end position of the gene. So you will copy this and make the file like that. So, and the other thing is the chromosome. So chromosome, it is like on which chromosome our gene is present. So this is also on the same database. So here you can see that the location of the gene, it is present on the chromosome 1. So in short, this you will make the file like that. So these are the two things, and the third thing is that we should have the information about the chromosome length, total chromosome length. For example, here firstly I will show you, uh, I have already created a file for you. So let me show you the file firstly. So this is my data set. I will tell you how to make this in the later stages. Firstly, I will show how it look like. So I will copy this and then click on the chart. So this position show that this is the starting point of the gene, but the third thing we need is the end point of the gene, end point of the chromosome. So how we will get the information about the total length of the chromosome? So now I am going to tell you this. Firstly, if you are interested in the Arabidopsis thaliana, so as my work is on the Arabidopsis thaliana, so I created the file of this, but for the legumes I will also tell you later. So for the Arabidopsis thaliana, you will just write the total chromosome length in Arabidopsis thaliana. Then here is the interface that's showing the option genome assembly. You will click over there, and here is the total chromosome, like the total 5 chromosomes are present in the Arabidopsis thaliana, and here is the approximate chromosome length. Of course, a chromosome will start at the 0 position and it will end at this position. You will copy this. You can copy all of the information like this, and you will make a file here, like you will paste it there. As we know that we are just interested in the total chromosome length, so we will delete the second column which shows it is a golden path length. So we will delete it, and now we have this file. So please arrange this file accordingly, like that. And the other thing is we have the gene name. I will copy this for our data and I will paste it there, and then I will copy the position and the chromosome. So here it is. So you will paste it there. So we have get the information about this. So we are not interested in the end point of the gene, so you will just delete it step by step, like that. So I am just deleting this. So you will delete it like that. I'm not going to delete all. It is just a wastage of time for me. So you will delete like that, and I will just copy the already start position that I have already made the file. So I will just paste it there. So in this way I have the three things, and now it is a time to divide the and it is a time to create the file. For this purpose you will create the file like that. You will just write the chromosome 1, chrome 1, and you will write it there, and then you will write the start, and the genes that are present on the chromosome 1, you will just copy them. For example, this. And one most important thing is that before copying them, uh, that we should keep in mind that the smaller number will be present on the chromosome first, and then the larger number. So this gene is present on the chromosome 1, but it is 17,000, so I will not going to write this. So here is another gene. So highlight it. I will going to highlight all my genes that are present on the chromosome 1. So it is like that, and you will write it like the smallest one first. For example, the 16. So I'm going to copy this and write it there. In the same way, 16 and then 17, and then 16, 17, and then 20, and then here is a 25. So I will copy this also and paste it there. And the next one is the last one, that is this 29. So I will paste it there, and here I will write the end. So uh, this is the okay. I will just tell you how to do the start and end after some time. So in the same way, the next chromosome is 2. So I will copy this and write the here chromosome 2, and I will write the all the genes that are present on the chromosome 2. So there is only the one gene that is present here. So I will copy this and paste it there in the same way. And oh sorry, I forget to add the start, and then here I will paste the gene here that I've already copied. After that, here is the option that is end. After that, here the next chromosome is 3, so I will copy this and paste it there, chromosome 3, and all the genes present on the chromosome I will write there. So first it is start, start, and here are the gene. So this 2 is smallest, so I will write it there, 2, and this is 5705. This is smallest, so secondly I will write it there. In the same way, after that it is there. three genes on the chromosome. So here I will write the end. So here I have written the chromosome 4, and I will write the start and the genes on the chromosome. So there are the two genes that are present on the chromosome. So this is the smallest, so I will copy this and paste it there. In the same way, paste it there, and then I will write the end. And there is only the one gene that is present on the chromosome 5. So I will copy this and write it there, like this is our chromosome 5. So there is the start, and here is the gene. So I will copy and paste it there. Okay, here is the end. So this is a file that I created, but this is a raw file as there are the spaces in it, two spaces. So I will delete it, these two columns, because uh, I I would like to tell you that we are not interested in the chromosome, as we already have mentioned here. These are the genes that are present on the chromosome 1, and this is a gene that is present on the chromosome 2. So we don't need this column. This is an extra, so I gonna delete this. So I will get the file like that. And now the next step is to write something in front of the start and end, because every chromosome start with the 0. So I will write it there 0, and the chromosome 1 end position is this. So I will copy this and paste it there. In the same way, start is 0, and the chromosome 2 end position is this. So I will write it there, and in the same way 0, and the third one is this. So I will write it there, and 0, and the fourth one is like this. Start is 0, and the fifth one is like this. So I will write there. Now this file is complete, but the thing is that when we draw the chromosomal mapping, so our scale should be the less than 100. So for this purpose, there are the mostly digit that are the 18 numbers. So I will divide this value with the 1 million. So for example, I'm going to apply the formula there. So I will click equal this value divided by 1 million, 1 with 60. So I will click the enter there, and we will get this number. I will going to drag it, so I'll have this value. So I think this is the invalid. I don't know why, but when I will divide this will be 0.2588. So I'll write it by hand. In the same way, I will apply the formula there, equal this value divided by the 1 million. So I'll get this value. I will drag it like that. So same the case with all of the values. So I'm not going to do this because for you I have already done this file here. So after that, what you will do, you will just copy them and paste it there in the specific manner, values and the number format, and you will click OK. So it has been copied there. So you will delete these two columns. So we'll get such type only the two columns. So in this way I will get these two columns, and the next step is just to copy this and open the map chart, and I will going to paste all the data there. Then I will just click on the chart there. When I click on there, then this file will open. So this is our chart. But before going to into the formatting of this chart, I will like to make you. I will want to um that I will like to make you aware. Like there are some mistakes that most of the student do. So the common mistakes are that here I have the three data sets. So this is our final data set, but here are the two data sets. The first one is that here in when I will just copy this and I will paste it in the software and I will click enter. I will click over the chat. So there is a problem showing that group expected but chromosome 1 is found. It's mean that the chromosome 1 is not the right way to enter the data. So it should be C, it should be like that. CHROM and then the number next one. So and the other thing is that when I will copy this data set, I'm sorry. Oh, let me open the file again. So it is here. So I will just make it. See what I do. I just copy this and write it there. In the same way, I copy this and write it there. This is a very important thing that I am going to tell you because most of the time such type of the problem happen. So that is why. So and apparently this file is similar to this one. So when I will, for example, I will also copy these two there. And when you try to, and these files are no apparently same. So when I will copy this and paste it again in the software, then there will be the error. The what is the error? Error is in the position of the locus this. So what is the error actually? So here you can see that on the chromosome the smallest reading should be first. So the point is that we should write the 2.6 gene with this position on the very start like in this file, and then the 17 one, and then the 12 one, like that. So when you don't care about the position of the genes on the chromosome, then you will not be able to get the correct result. So here are the two things. First is that you should be very careful about the title and title of the chromosome, and the second thing is the arrangement. So now I am going to formatting my chart. I'll go there and I will paste my actual data. I will click over the chart there. So it will appear like that. So I will go to the chart options. So here are the different options. So you can change the things by using them. So first of all that I found it is most important is the loci. When I will click on this, and there is the ruler at the page margin, it means that it should show a scale here. So I am interested in doing this, so I will click over there and click OK. So now it is showing the scale. So here is the chart option again, so you can select, you can if you want to change the locus found, so you will click over there and you can make them bold, and you can like 12, and here you can also choose the option of times new roman, but usually I don't do this. I'll click there and okay. So here you can see this. In the same way, you will go to the chart options, and here so this option is about the bar length. You can increase and decrease according to your desire, so it's depend on you, but I usually don't do this. uh, so there was an option that I wanted to tell you, page layout, color and lines, then bar. Yeah, this one is that. Here you can see that there is a round tip of the chromosome. So if here it is an option like round tips, when you will uncheck it and you will click OK, and you can see that this has changed into the rectangular shape. So this is all about how we map the genes, our desired genes on the chromosome. So if you have any question related to this, then you can ask me. This is all about the Arabidopsis thaliana. But if your crop is not the Arabidopsis thaliana, the method is the same, like how to create the file. But of course, the assembly will be different. Like Arabidopsis thaliana only have the 5 chromosome, but if you are interested in another species, for example, Vigna radiata, then of course the chromosomes will be different. So for this purpose, whatever your species is, so you will go to the NCBI, get the information about the gene assembly. So you will click here the gene assembly, and you will write your desired organism there. For example, I'm interested in Vigna radiata. I will search it, and here is the assembly of this, so I will click over there. So this is a genome assembly radiata. So here is the information about this, like who is the submitter of this data. It is a Seoul National University from the Korea. So here is that it is showing that Vigna radiata has a total number of chromosome 11. So here is the 11 chromosomes, and here is the detail of 11 chromosome. So here, from here you will get the idea that chromosome 1 has the length of this, chromosome 2 have the length of this. So there is another data about like GC content, unlocalized counts like that, but you of course this is not relevant to your input file, so you will just copy this and you will delete this column, and you will keep the size column only and the chromosome only, and then you will further do your analysis, like making